So I would appreciate if somebody would check the math on this again, just in case. First step is find your z-score. So we take our p hat, which we need to find. So p hat was the 68, I think, right? 68 out of the 300, which turns out to be 0.2267 roughly. So in our formula, we do the p hat minus the p0 over the square root of p, 1 minus p, those are both p0s, all over n, which in this case would be the 0.2267 minus the 0.301 divided by the square root of 0.301 times 0.699 divided by the 300. And my calculations say that this is negative 2.8. If I were drawing a picture, the interesting thing is, even though I got negative 2.8 on my scale, since we know that this is a not equal to, we also have 2.8. So don't forget about that. Now, there are a couple ways to calculate your p. You know that you could do 1 minus the stuff on the inside if you want to, or you can calculate 1 tail and double it. I'm going to calculate 1 tail and then double it. Okay? So there's more than one way to do this. I'm going to do the 1 tail and double. So my probability that my z, in this case, is less than negative 2.8 turns out to be, when I do my normal CDF, 0.0026. Okay? So the probability that I'm looking for, the p-value that I want, is going to be equal to that 0.0026 times 2. Why? Because there are 2 tails. So I actually get a p-value of 0.0052. Again, the reason that I'm multiplying by 2 here is that I have 2 tails.
So every time it's the...
Okay, so our last part is our conclusion stuff here. So we're going to say that our sample of 300 expenses had a proportion of, what was it, 0.2267. This would occur 0.52% of the time if the true proportion was 0.301? No?
Yes.
Yeah, okay. Since our p-value of 0.0052, remember 2 tails, is less than our alpha, which was equal to 0.05, we reject the null hypothesis. Or in other words, there is convincing evidence that the proportion of expenses that begin with a 1 is not 0.301. And what does this mean in the context of the problem? They should do a more thorough investigation. So you should add that. I ran out of room. AJ, was it AJL? AJL should do a more thorough investigation. Put that in at the end. Intervals. So in addition to our z-test that we do for the proportion, they might ask you about using a confidence interval. So as we look at this confidence interval, I'm going to go back to, we just did this JBL or whatever thing it was. Which one are we talking about? The Benford law. And so when I do this, I'm going to refer back to some of the stuff we already did instead of writing it all down again. You could do the same, but I just want to show you how it works with the confidence interval. So in the confidence interval, a few things change. First of all, when you're starting out in the beginning, instead of going H-O-H-A kind of thing, you start out like we have in the past and say, we want to find a, what size confidence interval do you think you want?
95.
95. A 95% confidence interval for the true proportion of expenses that begin with the digit 1. So that's one of the main differences. You don't start H-O-H-A, you start with our confidence interval statement. No big deal. The planning part is a little bit different because when you do this, you're going to say, we will do a 1 sample Z interval. Very good, Aaron. Interval for the P. Instead of saying test, it's called an interval. Let's see. What else did I have to do? So in our planning part, we have to talk about if it's random. We already know that. See number 3. We want to know if it's normal, same kind of deal. Yes, blah, blah. We want to know if it's independent. Yes, blah, blah, blah. So those parts are the same. So far, we talk about the test being a little bit different, right? It's the interval, confidence interval, instead of being the test. And we talk about how we start by talking about the confidence interval. The main difference, I think, is what comes next. And this is how you actually calculate the interval. This goes back to the stuff we've done before. So to find the interval, you take your p hat, like we did before, plus or minus your z value, times the square root of p, 1 minus p, all over n. Remember that our p hat was equal to 68 out of the 300, which was our 0.2267. So that changes a little bit of things here. So off to the side, we have 0.2267, which is our p hat, plus or minus our z value for a 95% confidence interval, which I believe was 1.96. And then it's times the square root of our success, which was 0.2267, or in other words, our probability there. And then 0.7733, which is the failure.
Wait, why are you using 0.2267?
Okay, so kind of strangely enough, our p hats are in both places under the radical and out in front. When we calculate this out, you find out that your confidence interval goes between 0.1793 and 0.2741. So just like in the past, we're looking at this interval going, okay, well, what does this mean for us? What do they claim?
0.301.
0.301. Is 0.301 in that interval? No. So we are 95% confident that the interval from 0.1793 to 0.2741 contains the true proportion of expenses that begin with a 1. Since the stated proportion of 0.301 is not contained in this interval, we believe this company should be investigated for fraud.
Yeah.
Yeah.
Yes.
Yeah.